Okay, so today what we're looking at is solving exponential equations with technology. Now, there's lots of different technology, and obviously it changes as time goes on. So when I first would have taught this lesson, I would have used the graphing calculator. But now there's so many more pieces of technology that are free and much more user-friendly than the graphing calculator. So that's what we're going to look at today. So our goal is I'm able to identify when common bases cannot be used, and I'm going to use the appropriate technology to solve the equation. So what we're looking at, for instance, this equation here, 3x equals 5. You can see with 3x equals 5, there is no way that I can turn that 5 into a base of 3. So what we learned the other day just isn't going to work. So that's the problem that we encountered. We cannot somehow change 5 into a base of 3. And let's face it, the world doesn't have perfect numbers that allow us to do that anyways in most cases. So what we're going to do is we're going to do a couple different things. The first thing we're going to do is we're going to take this equation 3x equals 5, and we're going to break it into pieces. So the first step we're going to do is we're going to break into two equations. Now the two equations that we're going to break it into are going to happen right at the equal sign. So we're going to go y equals 3x, so that's going to be our first equation, and our second equation is going to be y equals 5. Okay, so we have done that. Now the next thing we need to do is we need to find some technology that will help us. So the piece of technology that I'm going to look at is going to be Desmos. Now Desmos is an app that you can get for an iPad or your iPhone. But what I like it as well is I can just go to the website and get it as also, and it's free. So all it is desmos.com, and so I have this website up here, and you notice the first thing you see says start graphing. So I'm just going to press start graphing. Sometimes on the app you might have to press that a couple times. So this is what comes up, and at first it looks, wow, what am I going to do? But it's actually very, very friendly. You can, as time goes on too, we're going to be using this app. But the first thing you can see is you can see where the cursor is. It's blinking here at the number 1. And that is where we're going to enter our equations. Okay, it has down at the bottom, okay, if you notice there's this little keyboard that comes up and down. And I'm going to use that to enter our equations. So if you remember what our equations were, and I'm just going to minimize that a little bit so we can see it together, is y equals 3. So I'm just literally going to type in on the keyboard of Desmos y equals, as soon as I get that, equals 3 to the exponent of, okay, x. And notice it graphed it in red. And then I'm going to go down to number 2. You can see where my cursor is now. And I'm just going to enter y equals 5. So very, very simple to graph. It gives you quite a nice graph. I'm just going to, again, maximize it so you can see. I can close the keyboard on this. I can zoom in and out. So I'm zooming out. I can zoom in. I can move it left or right, up and down. So it's much more friendly than what a graphing calculator would be. So now what we have is we have this graph, and what do we do with it? Well, let's take a look at the next step that we would do. So we've taken our question, we divided into two equations, and you saw what I did next. What I did is I actually entered it into Desmos. So the next thing that I put for a step would be, the second step is input both equations. into desmos.com. Then what we're going to do is, and you saw that I was able to zoom. So you can zoom in or out, and what you're after is that point of intersection. So we're going to zoom in or out in order to locate the point of intersection. Okay, so we're after the point of intersection, and if we go back to our graph again, and I'll bring up Desmos again. Okay, so you can see where the red and the blue line graphs equations intersect. So all you have to do is, depending on what you're using, is if I was using my computer, I'd take my cursor and I would just touch where they intersect. It automatically gives you where it does intersect. And if you notice, it gives us a point. And the point it gives us is 1.465 and the number 5. So what does that mean then to our solution that we are working on here? Well, it means a couple different things. One of the things it means is that x is what we were trying to find. X actually equals 1.465. So we found with the zooming in and out and touching, so we should add that. We zoomed in or out to locate the point of intersection, and then we touch that point. Touch the point of intersection. I'm going to use short form point of intersection because it's much easier for us to do it that way. So we noticed that when we did it for this example, we ended up with 1.465 and 5. Now that makes sense because remember, we entered into our equation earlier, we entered in y equals 5, so it makes sense that the point of intersection is going to give us a y value of 5. So what we're doing here is finding the point of intersection using technology. Now, you've done point of intersection before in earlier grades because you did systems of equations. And systems of equations, again, you're after the point of intersection. So really what we're doing is we're creating a system by taking our original question and making two equations and finding where they intersect. Okay, so it's pretty much like that for everything with technology. Very, very simple using Desmos. If you've ever tried to find a point of intersection with a graphing calculator, you'll understand that this is so much easier. So let's take a look at a couple examples. So the first one is 3x equals 90. So remember what I said, we would divide it first of all into two equations. The first equation would be y equals 3 to the power of x, and the other one would be y equals 90. So again, I'm going to bring up Desmos, and I'm just going to enter those in. So the first one was, bring up this, y equals 3 to the exponent x, and the next one is y equals 90. Okay, again, you can see that it very easily graphed it for us. Now we need to, and I'm just going to bring back up Desmos, now we need to go look for that point of intersection. Now we know that y equals 90, so we know that it's going to be up, or we should know that it should be up by 90. Okay, so if you use the app, you know, so I keep taking moving it around because I want to spread it with my fingers because that's what I do when I'm on an app. So again, this app will do for you is it will give you certain points. Here, if you notice, it gave me when when it crosses the y-axis, but what I'm interested in is the point of intersection. So the answer to this one, first of all, we know that we have approximately 4.1. We don't need all those decimals, and 90. So if we go back to, and I'm sorry I keep going back and forth, if we go back to this one, what we ended up getting from Desmos was a point of intersection, and that point of intersection was 4.1 and 90. But remember, we're solving, and what we're solving for in this equation is x. So from our point of intersection, we're just after the x value, which is 4.1. Very, very straightforward. Let's take a look at another one. Again, you can see that it's not, hopefully you're seeing that it's not really that difficult for us. I just have to put it over here in order for me to see the equations. So again, I have y equals, sorry about that, y equals, get over here, 0.4 to the power of x, and my last one is y equals 25. Okay, again, I'm just going to have Desmos up for us to look at. Again, it's like, where is the point of intersection? Well, again, we have to look for it a little bit. So I'm going to zoom, okay, there it is. So I'm going to bring it up. I can zoom it in at this point because now I can see where they intersect. And they intersect right here. So the point of intersection is negative 3.5. And I'm just going to write that down so we can take that over to our note, and 25. Here we go. So what we end up having is the point of intersection was negative 3.5 and 25. So therefore we know our x value is negative 3.5. Really straightforward. I think we have time to do one really quick question, and the reason being is it's a little bit different in the sense something that you might come across that might throw you off a little bit, and that is when we have something such as, so this is the third example, 2 to the power of x minus 4 equals 15. So a little bit different, and the way it's different is you can see that the base of 2 is to a power of x minus 4. So here's our two equations that we're going to enter, and again using Desmos, we're going to bring that up. This is where the issue happens. So I need to enter y equals 2 to the exponent of x minus 4. Okay, so I have y equals 2, and when I do the power of, I need to put a bracket. And it doesn't matter which piece of technology, whether it's Desmos or the graphing calculator, you have to put a bracket for that x minus 4. Close the bracket. Otherwise, what happens is the technology will do 2 to the power of x, whatever that answer is, and subtract 4, and that's not what we want. And then we have y equals 15. And again, you can see that the point of intersection is here, which is approximately 7.9 and 15. So we'll bring back up our note. So we know that our point of intersection was 7.9 and 15. So therefore our x value is 7.9. Now really important to watch out for here is that x is 7.9. X minus 4 doesn't equal to 7.9. So when we take the technology, it's actually solving for the x, even though if we look at our beginning thing had an x minus 4. The technology is actually giving us the x value. Okay, so good luck with some questions. Any problems, let me know.